Hello, fellow techs. I have here a 2015 Hyundai Genesis, and the dealership gave up on it. They couldn't get it to start. It would crank and crank and crank, and it turns out that it has a sync issue where the cam and the crank don't sync properly. So I'm doing some in-cylinder analysis on it with the pressure transducer. I have here my WPS hooked up to cylinder 1's compression pattern. I have my number 1's ignition coil current for a sync so that we can see ignition timing. I actually also have my crank sensor for reference. I'm taking my capture here. Okay, we'll wait until we get to our, I'll let it go through one more time and capture another frame. All right. There we are. All right, we're going to stop it. Okay. And we're going to slide this over. All right, I'm going to slide this down just a touch. And I'm going to Windows print screen this and save a screenshot. All right, so there we just did our screenshot. And now we're going to go over to the computer. All right, so we're over here at MGDT now. I'm going to go ahead, and this is my Hyundai. I'm going to open the job for this Genesis, and I've actually been working on this for a while, so there's already some data here. All right, these are some of my other captures I've taken. All right, so we need to add the capture that I just did the print screen on. So I'm going to go ahead and remove this paper. That was covering our customer names that were attached, that were on the other page. So this is our job that's open for our Genesis, okay? And we are going to find files, all right? We're going to refresh our file listing. That's going to pull all the files that are new from the server, including our screenshot we just captured. All right, so we refreshed our files, and we are now going to change the date so that it includes today. All right, and we're going to show files, and it's going to show all of the files here for this date range that's selected, which includes today. I'm going to choose that computer that I just took the screenshot on, and that's our screenshot we just captured. Okay, so I'm going to select it, copy files. All right, we copied it, and now it's in our report, ready to work with. All right, there it is right there. That's the one we just captured. So we're going to edit it. We're going to click on the pencil. We're going to edit. And if you guys have heard me talk about Scopemate in the past, okay, that's actually what we're using here. Scopemate is now built into MGDT completely. So when you go into the edit, the editor for any of the screenshots or captures is going to be Scopemate. So we're going to click there. We're going to measure this in-cylinder capture. All right, now we're going to measure our exhaust valve opening point. And I don't really like it. Ended up, okay, so I'm going to slide this up here. And if you don't like your position you picked exactly, you can slide it around a little bit. Looks pretty close to 40 to me, okay, which is, as you guys know, pretty normal. I'm going to click on the intake valve opening point. It's really, really close here. There's 60 degrees. And that is basically what you would consider to be a normal pattern. And now we're going to measure our spark advance. So I'm going to come over here to where our spark happens. Looks like we're running about 7 degrees before top dead center on our spark or ignition advance. So now, if you happen to drop something in, and let's say that your exhaust valve opening point was not in the standard area. Of course, you guys know your exhaust valve would normally open before bottom dead center. So anything in this range, it's automatically going to select exhaust valve opens, okay? Now, let's say that this was actually over here. Notice it says intake valve opens. Well, that's not right. So what we need to do is we need to change our label. We would just change our label to what it happens to need to be. In this case, though, it's actually in the correct location. So we're going to slide this back. Notice it went right back to exhaust valve opens because that's the normal point. We're going to run that at 40. Okay. And let's say here that we wanted to highlight. So I'm going to change this to yellow. All right. And say I want to highlight that my cam timing points are normal. All right. Maybe I'll even want to add a note. Let's say that I want to say bank 1 cam timing. Normal. All right, and of course you got to turn off the text function, and once you turn off the text function, you can move this stuff wherever you want it. Maybe you'll want to draw lines to it. Whoops, didn't want to do that. Start on this end. So this gives you a lot of power to not have to export things to Photoshop to do capture markups, to export it or put overlays and different programs on here. Everything you need to document these captures is all right here in MGDT, ready for you to use. Another interesting function is the overlay function. So what the overlay function can do, okay, all right, we're going to load images. Now I got to go find my, see, that was Hyundai of Jefferson City. Jefferson City, there's my car. Okay. I'm going to choose this one and this one. Open. All right. Now I'm going to click on a color I want to remove. In this case, I want to remove the white background. All right. And what it's going to do is it's going to remove the background from everything. All right. So then what you can do is you can actually directly live overlay captures. So if you have one capture that you want to directly compare to another capture, now notice the timing points don't exactly line up, so we have to adjust the scaling just a little bit. We're selected to this one, and it's just a little bit smaller, so we need to increase the scaling and get it to line up. But there, you can do a direct overlay and see, like in this case, we're comparing one bank to the other. Notice there is actually a timing variance between bank 1 and bank 2. You can actually see it there when they're overlaid. So this comes in really handy. Like I've used this method before. I had a 5.3 that had a bad cam follower. And when I used this method, it literally stuck out like a sore thumb compared to all the other cylinders. It's pretty cool. So you can do that. But this allows you to have full capability. Oh, I didn't save it. Whoops. All right. So we're going to edit. All right. So we've got this. I want to put this back the way it was. Okay. 60, 40, and Spark Advance. I messed it up. I forgot to save it. If you're too close to the final 720 line, it may not put in the, it may not drop in the. Okay. So when you're done with your capture or you're done marking it up, all you have to do, hit close. It'll ask if you want to save. Sure. All right. And there's our marked up capture. Puts it in your report ready. I may not like where it is. I'm going to move it back here with the other ones. Okay. So there we go. And then when you choose your shop, it automatically loads the shop's template, which automatically types up your write-up based upon your templates that you have set up. Now, this particular vehicle was a diagnostic situation, so I couldn't really use a template. I had to manually type most of this. But once you do that and you've got your write-up done, you just hit Create Document. And when you hit Create Document, it pops your write-up. Now notice it's sticking. I'm going to have to modify this just a little bit. I'm going to add one line. And I'm actually going to get rid of the 5.0 GDI. Okay, now we're going to create document. Notice it changed. Now we got rid of that, so it's not close anymore. And here's our full write-up of our job. Okay, when you have your job the way you want it, you just hit merge. And it'll say report generated. Do you want to review it? You want to view it in job directory? Sure. All right. So here's our full job directory that MGDT built on our job. Here's our final report. So there's our write-up on our job. There's our scans. There's our known goods. There's our cam captures, relative compression. There's some of my others. There's my picos. And what's interesting on this vehicle, and I didn't explain, this vehicle was losing sync. So it would say sync yes, sync no. And it would try to start when it said sync yes, but it would say sync no, and it would stop firing injector pulse and injectors. But what I ended up finding was when I scoped all 4 cam sensors, notice bank 1, exhaust cam, bank 2, exhaust cam. These things should match. Notice the overlay of bank 1 versus bank 2. See how the falling edges line up? Falling edges line up. See that? Falling edge, rising edges, they line up and match. But look at bank 1 versus bank 2. So I'm like, well, that doesn't seem right, especially when this looks like bank 2, which is the problem child. The left bank exhaust cam looks like it's late. The other thing is, this particular car starts when you unplug bank 2's exhaust camshaft sensor. It fires right up perfectly. Otherwise, it'll sit there and crank forever and try to start, but won't start. So at any rate, our bank 2, or our left exhaust camshaft sensor is falling at the wrong time. What's really interesting is if you look at the captures, notice here's bank 1, 40, 60. It's the one we just did. Okay, look at bank 2, 50. Exhaust valve opens at 50, but notice the intake is still right, 60. So there is variation in the camshaft on bank 2 exhaust. Here's what's interesting, all right? This one's early. However, this one's late. So how can our camshaft be late, but yet, as far as the sensor's concerned, but yet as far as our in-cylinder is concerned, our cam timing is early, 10 degrees early, actually. Well, let me show you how. Somebody had a welder. So basically, I suspect that this vehicle has an issue with the cam phaser on the exhaust cam on bank 2. And this came from auction, not running. And this thing would never start for him. And it was an in-op at the auction. I think somebody was trying to maybe pry on this reluctor or something to reposition it. I don't have any good explanation except for the fact that you can see the undercut of the welding here. Somebody apparently broke the cam sensor reluctor and then tried to fix it. Well, when they got it back on there, they got it back on there late. And after they did that, it would never start again. So yeah, this was an interesting one, and I wasted quite a bit of time there. I actually measured it with Scopemate. The exhaust cam is 17 degrees late. I just set my 720 point between here and between here, and then I just measured. I dropped in a degree measurement here, dropped in a degree measurement here, and subtracted them, and it was 17 degrees is how late the exhaust cam sensor reluctor is falling. So it was a really good one, really interesting Diag, and it was a really good way to highlight the power of the scope, because this car would have been really hard to definitively diagnose without the scope, and the dealer actually gave up on it. So guys, thank you so much for following along, and I look forward to seeing you guys in the next one. Hopefully you guys can take the time to like, follow, share, repost, whatever. Really appreciate it, and take care, and we'll catch you on the next one, guys.